We can determine the multiplicity of a zero graphically or algebraically. So let's take a look at how to do this algebraically. So I have an equation, g of x equals x minus 4 cubed times x minus 2 to the 8th. So all you're going to do is t off. So I have x minus 4 equals 0, which means that x equals 4. And then on the left side, I have x minus 2 equals 0, which means that x equals 2. Those are my zeros. The multiplicity comes from the exponents. So x equals 4 has a multiplicity of 3. And x equals 2 has a multiplicity of 8. Number 2. H of x equals x squared minus 6x plus 9. So it's not in factored form, I need to factor it. So I'm going to take this trinomial and I'm going to factor using AM. So I have two parentheses, they each get an x. I'm looking for what multiplies to 9, and I'm going to use my sign trick. So I bring down the negative. A negative times a positive is a negative. And then what multiplies to 9? 3 times 3. Which, because it's the same binomial, can be written as x minus 3 squared. So I have h of x equals x minus 3 squared. So when I t off, I only have one piece to t off with. I get x equals 3, and my multiplicity is 2. So just as a little recap, to determine the zeros of a polynomial algebraically, we factor, t off, and solve. And then to determine the multiplicity of a zero, we look to the exponents. And that's algebraically determining the zeros and their multiplicities. Now, if we wanted to determine the degree, we're just adding our multiplicities. So if I go back and take a look at this, number 1, I had a multiplicity of 3 and a multiplicity of 8. So my degree is 3 plus 8, which is 11. In number 2, my degree, I have two options here. I can look at the multiplicity, which is 2, or I can look at the standard form equation that was given originally. The largest exponent is 2. So that's, once again, multiplicity and zeros algebraically, and then just a little recap with the degree as well.